All right. Welcome to another edition of the engineering side of data. Video edition, that is, audio and video. So we're going to be talking about data pipeline testing on this episode. And I have a great guest lined up for you all out there. His name is Bartosz Mikulski. Bartosz, please introduce yourself.
Hello, so I'm Bartosz Mikulski. I'm a data engineer right now working on more like MLOps part of data engineering. I'm blogging, so I have a blog, but it will be linked somewhere. I also happen to speak at conferences occasionally. And yeah, that's pretty much about it.
Excellent, yeah. Now, I've been following you on Twitter for a while now, and you like to tweet about testing. And then
yes, that's probably the main topic I tweet about. Not very often, but yeah. That happens.
So yeah, I will. I'll put a link to your blog that you mentioned in the show notes and your Twitter handle as well, and any other relevant information that will be out there in the show notes and the description of the video there. So I appreciate you coming on, talking about data pipeline testing. All right, so let's get right into the topic here at hand. What are the different types of tests? So when I say data pipeline testing, what does that mean to you? What do you think about?
Yeah, it's kind of tricky because it's not only testing the code. Yeah? The code is important. We have to test it anyway. But in data pipelines, you have like two moving parts. So it's either the code, you modify it, but also the data changes like all the time. And usually what breaks the pipeline is a modification of the data that even not done by us, but someone else who has generated it upstream. And we are not notified before it happens, or maybe we are, but anyway, something has changed and we have to deal with that. Also, if we have machine learning component in our pipeline, that might break also because of concept drift, so the data changes and the model doesn't work anymore correctly. So it's pretty much, we have two things to test. It's our code and the data that we get.
Yeah, that's what really makes it tricky, right? We can write unit tests much like software developers can and should. And then, but we also have that additional tricky component of the data side of things, whether it's or it ends up in a data warehouse or in some model that'll do some scoring or predictions, right? Definitely. So why should we as data engineers test?
Well, first, but our work has one purpose. Yeah? We have to deliver the data to the customer, the client, whatever. Yeah? Someone is using it. And this person or organization has to be sure that the data is correct. So the only purpose of testing is making sure that what we deliver, the final product is, let's say, working. Because otherwise it's kind of pointless. Yeah? Everything we do is pointless if the data is not correct.
Yep. Yeah, it's about that trust, right? Establishing that trust that if we put something out there, it's good, right? People can count on it. They can bank their reports on it. They can run their models on it. Absolutely. Why don't more data engineers write tests, you think?
Yeah, because it's difficult. It's not like testing the backend software. As you said, we have unit tests, we may have integration tests, and that's pretty much the obvious part. But then you have to test the data, and it stops to be easy. Yeah, because there's a lot of tooling for the testing of the code. And you have metrics like code coverage, so you kind of know when you finished or when it's good enough. But what about the data? It's never finished. It's never good enough. And it gets trickier. So we are not even sure if we have achieved the goal. Yeah. Because you will know when there is a bug that you were not doing it correctly, like the testing. But until you detect the bug, you don't really know if it's good enough or not yet.
Yeah, I would agree with that. Yeah. When should we be writing tests, right? And I guess this is more on the code side of things, right? Should we be writing at the beginning, during or after the development has taken place?
Yeah, I think that a lot of people might expect the answer that at the beginning, and that's definitely a good idea, but realistically, I think we will write it at all of the stages. So some tests at the beginning, some during the development, and some additional tests at the end when we have everything ready, but we want to test a few more things that might happen. So we expect some problem and we also test this. So I think what we might try to set some rules, but the only thing that matters for me is if you trust the test and you are sure that everything works, if the test passes, it is good enough, and it doesn't matter when you write the test. But to achieve this goal, you will write them at 3 different stages, like at the beginning, before the code, during the development, and after.
Yeah. In that beginning, some people call that potentially test-driven development, correct, at the beginning? Or that's one methodology that you could incorporate, correct?
Yes, but in case of testing the data, I think that might be not very effective. But obviously, for testing the code is probably the best idea. At least if you can do it, then definitely it's worth trying. Obviously, it is hard. Yeah. It's not the easiest way to do it. But it's not going to be perfect, definitely. You can always improve it, but that's the good direction to go. Yeah. Try the test before.
It depends. That's probably the good answer there. Yeah. And that's, good distinction between code and data, right? Yeah. As I said, I follow you on Twitter and I've seen some of your talks, and you're a big fan of functional programming. Why do you think that's important when it comes to writing code tests?
Because of the principles of functional programming. Because in functional programming, you have immutability and pure functions. And immutability ensures that the data does not change. And that's a good property to have in your data pipeline, that the input does not change. And also, you don't modify it. Yeah? So you either produce something new, or you do nothing with this input, but you don't change it. So you can run the same pipeline again and get the same result. And for that, you also need these pure functions that produce a value that depends only on the inputs. There are no side effects. And if there is something that's generating some values randomly, you have also the seed for this random generator as the input, so you can repeat the pipeline later with the same inputs and get the same results. So that's probably the most important part that you need for testing. You get the same input twice and you have the same output. If that's not the case, then you have bigger problem than not having a test.
Yeah, very deterministic, and also easier to understand what's going on in a function, right? So if it's very clear what the function is doing, the tests that you write will be very clear as well. And I'm referencing some of the points that you made on a talk, and I can post that in the show notes as well. But that point was really driven home, I think, quite well by yourself. And this idea of, hey, if you have pure functions, you have very readable tests. And I think that's important. Yeah.
Yeah, and you can compose the functions like in functional programming. In this case, it's going to be a composition of part of the pipeline. So that's also easy to understand. Well, maybe not easy, but at least easier than if you had code that modifies the state.
Yes, I agree 100%. And I think that people think of functional programming, and could be a very daunting concept. I mean, let's face it, most data engineers maybe didn't start their career, or maybe they're a little behind on data and functional aspects. Maybe it seems daunting, but if you just could remember, that aspect of pure functions, that would really help you out and make things much simpler as opposed to much more complex. So, which is always good. Very obvious statement.
It kind of limits what you can do, but that's the reason why we do it. Yeah? This limitation gives you some confidence.
Yeah, give you some guardrails, right? Make sure. I agree. Okay, so we've talked about a lot about the testing code so far, and let's talk about testing of the data. Right now, there's a couple of tools that are out there. Actually, there's probably more than two, but the ones that come to mind are Great Expectations and DQ. How do they determine good data from bad data?
Well, they don't. You have to prepare the set of expectations or validation rules, and then the tool compares your data set to those rules. So if the conditions are met, then the data set passes the validation. If not, then you get some kind of error. So there is no magic in these tools. Yeah? You have to do your work anyway.
Yeah.
You have to set those validation rules, which means you have to do some data exploration to figure out what can happen in the data. You probably have to understand how the data was produced. So you need some business knowledge to understand what can happen, even if you don't see it in the data set.
Yeah.
That's also the reason why testing the data is tricky. You need a little bit more than just for testing the code.
Yeah, I've used Great Expectations in the past, and if I recall correctly, you can set those expectations, manually, or you can say, here's a data set that I would consider good with values that are within the ranges I expect, right? A normal distribution.
Yep.
And then you can pass it, and then it kind of says, okay, now I have the context to evaluate future data sets on your behalf. Yes, I think that's a pretty handy little feature.
Yeah, but if you use the data set, you also have to be sure that this data set is kind of representative of the production, because if it's not, then just test that doesn't work.
And I imagine you just can't train it once, so to speak, and then let it sit. It's probably a periodic adjustment, or at least a testing to see if your ranges, your tolerances still hold true after a while. Again,
it's kind of,
go ahead, sorry.
It's kind of like with machine learning. You have trained the model, but then the data in production changes, and the model is trying to produce something, but it might make no sense anymore.
Yeah, I could see that. Now, you mentioned that when these tools see, or a range, a value of a column falls outside of a range, right? And you get an error. How do you recommend that's typically handled in production? Are those errors logged? Are there notifications sent out? What have you seen as a good way to kind of mitigate that bad data once these tools find it in production?
I'm not sure if that's a good way, but what makes sense for me is like separating the data into like maybe two buckets, like the data that is correct and data that is incorrect. And then you might have some manual process of reviewing the data that you rejected for whatever reason. Because when I tried setting up some warnings in, for example, Slack channel that something is wrong, it's usually you get a lot of those notifications and all of them get ignored. So it's kind of pointless to have this test in the first place.
Yeah.
So maybe we need a different process for it, like separating the data, doing whatever we can with the correct values, and then like every month or every week reviewing the rejected values and see what we can do with that. Of course, if we have some data that must be processed entirely, we cannot lose anything. For example, financial data, then probably the only thing that makes sense is stopping the pipeline. You detected the error, something is wrong, we have to deal with that right now. It cannot wait. But, it depends what you're doing.
That makes sense, right? So you can either set that data aside, potentially, depending on the severity of it, the criticality of it. But again, and like in your example, financial, maybe you need to stop the presses, so to speak, and fix whatever data issues that can be fixed and then resume before. It depends on the urgency, I imagine, as well. We've talked about Great Expectations. We got DQ, things like that as well. But one of the more novel ways that you can use a tool in testing is LakeFS, right? You spoke about that before. What is LakeFS, and what does it do now? What would it allow you to do that would be incredibly difficult or impossible to do in the past?
It's not a testing tool, but what it does. It's sort of like branching of code, but for data. So you can have the production branch with your data that is currently used in production. Then when you want to ingest some new data, you create a new branch, like you would do with code. Then in this branch, you ingest the data, process it, and at the end, before you merge it into production branch, before it's ready for the processing or whatever you want to do with that, you run your tests. So if something gets merged to the production branch, you know it's correct, and everything that does not pass the validation is isolated. So you don't have to deal with corrupted data sets in production because you have it somewhere else.
Nice.
And that's the point of using this tool. Actually, the only feature of it is branching and atomic merges. So you have either everything merged into the production branch or nothing. Yeah.
Okay, that makes sense. Yeah. So the possibilities that you've seen or have used yourself have been in production, right? You create this alternative branch, and then when everything's been verified, you merge it into main. And I imagine you could probably, I'm sorry, go ahead.
It's like, I think people were using the concept of staging tables for this in the data warehouses. So you put every new value into the staging table, then you prepare it in some way, process it maybe, and then you insert it into the production tables. And this is the same, but for the files in data lake.
Yeah, nice. And I imagine you could probably use it during the development cycle as well, right? If you're going to try out a new transformation, you could, without disturbing the main test branch or whatever, you can create another branch and try out that what if and see the results as well. Yeah, the first time I saw that project, I was like, wow, this is something that would be great. And yeah, I'm glad it's around, and it seems to be an incredible tool, and I suspect adoption will be increasing greatly as the word gets out. All right.
No problem. I mean, this may be difficult to introduce to existing pipeline because you have to prepare it for data in a different location. But if you are writing something new, then that's no issue that you might have by adding it.
Yeah.
Just add a few lines of code. I think it's less than 8 lines of code, and you have it.
Yeah. And we should say that it is kind of aimed at the object store providers, right? So S3, or maybe that's my understanding. It's S3, it's Azure Blob, things like that. Maybe GCP storage as well. Those are the primary. Yeah.
I think it's mainly S3 and everything that is compatible with the S3 API.
Okay, that makes sense. Okay. Can you recommend any books, any resources on testing? Like if someone comes to you and says, hey, what do I want to be better at testing. I've been bad at it. I avoid it. What videos, what books do you point them towards?
I think I would point that person to YouTube and the videos produced by J.B. Reinsberger and maybe Martin Fowler, but in this case more to the blog than the YouTube. Because they have some good idea about testing. Maybe not all of them are very widely used.
Yeah.
Like maybe the J.B. Reinsberger is saying that integration testing is a scam. And he has some different way of dealing with those kind of problems. But I think even if someone does not agree with that point of view, you probably should watch the video anyway and learn some alternative way of testing. Yeah?
Gotcha. Yeah. How do you? So you've outlined some good resources there for testing. Now, how do you persuade? So someone said, "Hey, why should I test?" What do you tell them? I mean, we talked about that a little bit at the beginning of the show, but what kind of techniques or what kind of arguments do you use to persuade people to write tests?
The problem is that nothing works. Yeah? You cannot persuade people. You can show them that you test and it gives you some benefits. Like you can finish the work faster, you get less errors. And finishing the work faster is kind of obvious in data engineering, because if you compare the time that you need to make some changes and run the pipeline, and you compare that with running some tests locally, and you see a difference. Yeah? It's not like 1 minute, but that's usually 1 hour or more. But that's kind of easy to demonstrate. And I think that's the only way to persuade someone, just for the results. Yeah? Because you cannot argue with the results. Yeah? You finish something earlier and it works. So apparently the method is correct. Yeah.
You can only argue with results on social media. Outside of that, outside of that, you can't, right? Now, all right. So we have tools like Great Expectations, a host of great like PyTest is one of my favorite unit testing tools for Python. You got Great Expectations for the data. You got great things like LakeFS. What else can we do? I mean, those things are great to make things easier. How do we make things even easier than that? Right. What are some of your thoughts around that?
I tried behavior-driven development just to have the specification in more business-facing way. It doesn't mean that you have to show it to anyone, but it means that you might write it in a way that you understand what's the business case, yeah, and then you have the code that is testing the specification, like implementing the specification in a way that you can test the code. That might be one of the ideas that.
So you're talking about having business users write tests to some degree, right? Like, here's what I'm expecting this data to look at.
Yeah, that's probably not going to happen. Like, nobody will write the test for you, but you might ask for clarification, and then you write the specification and the test for it. And yeah, you have two benefits. You have the test, and you have the explanation regarding what happens in the code.
Yeah.
So that might be a good way. I'm not sure yet if it's a good way, but I'm trying to test it. Yeah,
I can see that. I mean, at least from a realistic, as developers or engineers, we can assume what's a good data set, which Great expectation we should set, and the ranges involved. But if we have a business user there that knows the data, or perhaps an analyst, they could help write those tests. And if we could somehow bridge what they know with the actual physical test, that could be, I could see that being easier and make our tests more effective. Absolutely. Yeah. All right. Well, hey, thanks for coming on the show, this episode. I really appreciate it. Folks at home, please subscribe, like the video. I'm going to get the audio out on the usual podcast destinations, wherever you subscribe, and then we'll get this video up on YouTube as well. All right. Thanks, Bartosz. Appreciate you coming on.
Yeah, thank you for doing this.